So our next speaker is Dr. Michael Bodnar. So Michael completed a PhD in neuroscience at McGill University under the supervision of Ashok Mala and myself in 2011. He will be presenting the results of that PhD shortly. Since then, he has started a second PhD, this time in the field of clinical psychology. So the title of his presentation today is Early Identification of Neurobiological Markers of Remission.
Wow. Thank you for the wonderful introduction. So as Martin just said, this work was completed during my PhD here over the last, I guess, number of years. I'm not going to say how many. But it was basically only possible through the collaboration between PEP under the direction of Dr. Mala and Dr. Lepage's neuroimaging lab. So we shall begin. For the presentation today, I'm just going to start off by saying why should we study remission? How do we define remission? Just a short little overview of our data collection. And then I'll present the results, our neurocognitive and neuroimaging results, and then just a brief conclusion for time purposes. So why do we study remission? So basically, I think as we've heard today, outcome from schizophrenia is quite heterogeneous. So a recent review by Robin Emsley showed that recovery rates are between 4% and 31%, and remission rates actually vary between 18% and 88%. So we can see that there's this quite heterogeneity of outcome from schizophrenia. So that heterogeneous outcome, in addition to the current ability that we have to predict an early outcome, has led to a trial and error treatment strategy, so that there's these ongoing assessments, careful monitoring of the clinical response, and the clinical monitoring of the adverse side effects. And this has led to a great challenge right now in schizophrenia research, and that's to better understand this heterogeneity of outcome following a first episode of psychosis. And one way for us to get this better understanding is to identify markers, specifically, let's say, neurocognitive or neuroimaging markers related to clinical outcome. And in this specific examples, it's remission that we were looking at. So how is remission defined? Well, until 2005, there was no definition that was used by all. And it was in 2005 that Nancy Andreessen and the consensus group came up with this definition that could be used across all clinical trials or any clinical program, basically. The definition has guidelines for all four major rating scales, and in our purpose, we use the PANS. And what the PANS is, it has 7 positive items that it can measure, 7 negative items, and 16 general psychopathology items. In order to have a remitted state, they propose that a person should have mild or less, and in the case of the PANS, that's 3 or less on all 8 of these core symptoms. And these symptom ratings have to be maintained for at least 6 months. These 8 symptoms were chosen because they're the most diagnostically relevant for schizophrenia. So this is just a brief overview of what our data collection looks like between PEP and Dr. Lepage's lab. So when a person is admitted to PEP, basically the initial symptom evaluation is conducted within 1 month of entry. There are 8 evaluations over this 2-year treatment period. Our lab, what we are doing is we're collecting neuroimaging, neurocognitive data. Is it falling? Okay. We collect neuroimaging or neurocognitive data at initial assessment and follow-up about 1 year later, and we also collect neuroimaging data over 3 time points, so basically at an initial assessment about 1 year later and about 2 years later. Following that same timeline, you can see that we were interested in investigating early remission, and our 6-month criterion was actually between month 6 and month 12. Looking at our remission rates, it's around 20%, but that's still in line with other studies that have used the consensus definition. And I must point out that this remission rate is specific to those that are afflicted with first episode of schizophrenia, not the effect of psychosis. From that, we looked at the 12-month separation between remitted and non-remitted, and we compared the 2 groups on neuroimaging and neurocognitive data. So looking at the neurocognitive data first, we compared them on 6 domains, and these 6 domains were put forward by the Matrix Consensus Group because these are the core deficits that have been considered central to the understanding of schizophrenia and outcome. And as you can see, our first episode group here functioned well below that of our control group. Separating that first episode sample into remitted and non-remitted, you can see from the blue line that the non-remitted function below the group average and the remitted function above the group average. Further analyses actually showed that it was verbal memory only that significantly differed between the two groups, the non-remitted and remitted. This was an interesting finding in itself, that it sort of provided an idea that the areas that would be neurobiologically different may be related to memory areas per se. It's not for sure, but it was a good direction. So when we actually looked at our neuroimaging data, the first step that we did was a fully automated technique, VBM. And what this does is it takes the whole brain, and we were specifically interested in gray matter, and we compared the whole brain between remitted and non-remitted. And what we found is that there was less gray matter in the right parahippocampal gyrus and the left hippocampus. And with my wonderful pointer here, you'll see for the parahippocampal gyrus, it was the more posterior area, because here's the parahippocampus, and for the hippocampus, which is right here, you can see again it's the more posterior region. So we wanted to verify these findings because there are innate problems with VBM. I'm not going to get into the details of that, but we manually traced and calculated the gray matter volumes of the parahippocampal gyrus and the hippocampus. We use a validated protocol that has been set forward by Jens Prusner. He's a corroborator here at the Douglas Institute. For the parahippocampal gyrus, it's separated into 3 cortices, and for the hippocampus, it can be separated into 3 subregions. We also were interested in calculating the volume of the amygdala, as it's sort of part of the hippocampal amygdala complex. And we verified our wonderful results. So what we found was that the parahippocampal cortex is indeed lower gray matter volume in the non-remitted compared to the remitted, and this was significant on the right side after correcting for multiple comparisons. For the hippocampus, there was a difference in the hippocampal tail region, but not in the body or head subregions and not in the amygdala. And again, it was the left side that was significantly different after correcting for comparisons. So we decided that we would run correlations with these 2 regions that we found of interest, the parahippocampal cortex on the right side and the hippocampal tail on the left, but we ran all of them. But for our interests today, we found a correlation for the right parahippocampal gray matter and social withdrawal. It was a very strong correlation, and it also correlated with verbal memory. There were no significant or even trend level correlations for the hippocampus gray matter at all with anything that we investigated, any of the core symptoms with remission, and none of the cognitive domains that we had. This was an interesting finding for us again, in that remission takes into account both positive and negative symptoms. So the findings that we have here with the parahippocampal cortex and the hippocampal tail involve both positive and negative symptoms. The correlation with the parahippocampal cortex showed that perhaps part of that remission definition, this finding was more related to the negative symptoms, and in this case more specifically perhaps social withdrawal. And now we'll go on to the fMRI task that I will briefly explain just for the purposes of time. So when the participants were put in the scanner, they were presented with either related items, so a first aid kit and a Band-Aid, or unrelated items such as a shirt and an iguana. They were also oriented towards 2 types of encoding strategies. So the first one asked the question, which one is bigger in real life? So the participants had to sit there, look at the 2 images, and draw association, but pick one which was bigger in real life. In this case, we hope they picked the first aid kit. The other question was, is one item alive or not? So for this encoding strategy, they didn't really have to draw an association between the 2 images. They just had to briefly look at the images. One's alive, they say yes. After they were done in the scanner, they had to do a simple recognition test where it's just, did you see these 2 images or not? The answer was yes or no. So from this data that we collected, we could do 3 contrasts. There was a semantic relatedness contrast, an encoding strategy contrast, and also a subsequent memory contrast. For our actual results, the significant differences that we found between the non-remitted and remitted groups were specifically related to the semantic relatedness contrast. And what we found was an increased activity in the non-remitted compared to the remitted in the posterior cingulate. This is a memory region. I'm just going to briefly explain how this is related to memory, and let's say in the case of schizophrenia. So the posterior cingulate is involved in forming memories. So when someone is not mentally engaged or in a resting state, the posterior cingulate is actually hyperactive. It's an overactive state. When mentally engaged, it's supposed to reduce in activity, allowing us to have more attention and focused attention, and therefore if it is a memory task at hand, you could actually potentially have better memories in that case because you have that focused attention. Studies in schizophrenia have actually showed that this increased activity of the posterior cingulate actually remains overactive when they're mentally engaged. And this actual hyperactivity is related to worse memory. So some researchers have come up with the idea that perhaps in schizophrenia, this posterior cingulate fails to turn off, leading to an oversampling of the stimuli around or unfocused attention, and perhaps a poorer memory. We did verify this with our group, but we suggest that this finding may be more specific to those that don't remit, so that those that do not remit may have a failure in turning off the posterior cingulate, therefore related to a poor memory in the end. So it was a lot of results in a short time, because I seem to be pressed for time, but basically the non-remitted have a poor verbal memory. They have a smaller hippocampal tail, smaller parahippocampal cortex, again in the more posterior region. There was also this abnormal activity in the posterior cingulate. So taken all together, there appears to be this memory-related neural network that are different between those that achieve remission after 1 year of treatment and those that do not. Again, like I said, remission includes both positive and negative symptoms. So what we showed with our correlation is that the parahippocampal cortex was related to social withdrawal. So either these markers that we've identified may be related to the positive symptom aspect, the negative symptom aspect, or both, just remission concept itself as a whole. Further studies are obviously needed then to verify more of these findings that we've showed. So for a brief conclusion, I hope this will increase our understanding of clinical outcome itself, that there are markers related to outcome, and that it could also increase our understanding of schizophrenia itself. I want to highlight that those that actually achieve remission or those that do not achieve remission may or may not show any or all of these markers. Of course, that wouldn't be the case. This was a group average. We were looking at a group as a whole. But we're not trying to discount these findings. What we're trying to say is that there is these areas of interest that could be specifically looked at in future studies that examine clinical outcome or remission. Or on the other tail of that, these are specific regions, let's say, for activity or even structural regions that could be looked at for developing newer target-specific treatments. So these treatments could be provided earlier on, let's say, in the treatment process if these people are identified with these markers and perhaps providing them with a better chance of having a better outcome in the end. And like I said before, I'm going to reiterate this last point that the negative and positive symptom aspect of remission is alive. So we've identified markers related to remission, but we have to identify what the specificity of these markers are. Are they more related to the positive aspect, or are they more related to the negative aspect? And actually, Cindy Hovington, who will be presenting next, we've started examining the persistent negative symptoms in first episode psychosis. She'll be covering that. So for my thank you, I want to thank everybody basically at PEP. Without them, all of this stuff that we've presented here would not be possible for sure. The clients would not be receiving the treatment that they require. All the former and current lab members that I've worked with over the years, basically without them since the beginning, there would be none of this data to work with. And finally, I think the most important thank you has to go to the clients, because, I mean, they're afflicted at the beginning with this first episode, and I mean, they're going through a lot. They're showing up for all these appointments. They're being questioned. They're being bombarded. They don't know what's going on, and yet they give their time for our research purposes. So I think the most important thank you is for them. So thank you.
So thank you, Michael, for a nice example of a third-generation brain imaging studies. So we have time perhaps for one question from the audience. Yes. Yeah, I'll repeat. Yeah.
If this region of the brain is involved in memory and it doesn't shut down, could this phenomenologically be interpreted as the person is having difficulty understanding the current context, using memories, and then going, aha, okay, I know, let's let go and move on to focusing on something else?
I'll try to paraphrase your question and repeat it for people who haven't heard. So you were talking about the brain region being overactive in the group who are non-remitted group. So what was the implication of that? That's very paraphrasing.
Yeah. I just trying to understand, but from what you said before, the point of your question, though.
Okay. The idea is that usually if we're trying to make sense of something,
yep,
we connect to our memories and we make enough sense of it
okay,
to be able to let go and then keep on functioning.
Okay.
Does this mean that remaining overactive means that they haven't gotten to that point of, oh, okay, I understand this, I can move on to paying attention to something more
Okay, I don't know if I would actually go that far and say that it was based on the memory that they have to like turn it off or turn it on. I don't know, but it was just during the task that we were able to show that. So maybe in real life, perhaps that is the case, that they're unable, that perhaps that could be there. But I mean, what we need to verify any of this, first of all, is just to have a resting state fMRI task, just to see how the activity of that posterior cingulate, let's say, or any other region that's implicated in memory functioning is active or not active during a resting state, and then perhaps have multiple stimuli presented and see how that differential attention can be refocused or not refocused. So I can't actually say if that would be or not.
Okay, so thank you, Michael, for your...